Hi, everyone. I'm excited to be here with you today to discuss some topics I'm very passionate about, open source and databases. And I wanted to start by thanking the organizers of this conference and all of you for attending. It's really great to have events like these to share with like-minded people and to learn from all of you. And so these days, when it comes to data storage, we're really inundated with options. And with that comes the need for well thought out choices. Do we buy, do we build, or do we deploy and self-manage? And I'll talk about these questions some today, but our focus is going to be on deploying and managing open source databases. What do we have to consider? What is there to account for? And what approaches we can take to be successful? So a few years ago, this wasn't as true, but it's really rare these days that the need arises for us to build our own database from scratch. Even with the surge in AI and vector databases that it's brought us, we already have like many options. And so a lot of times the build question isn't the one we're focusing on, or at least building from the bottom up. And so we're going to largely leave that question aside. But today we're most often presented with a choice between a third-party cloud offering, whether it be from one of the big cloud companies or from a startup, or taking an open source database and deploying it ourselves. And so why would we want to own and manage the database ourselves? The answer to that question largely comes down to control or ownership. When we deploy, we control our quality of service. We take it into our own hands. We control how the system integrates with our internal tooling, our alerting, our monitoring, the rest of potentially our platform, which is most often how these things are offered these days. And perhaps most important in our present economy, we can control the costs. So in deployments I manage today, cloud offerings regularly save money for the small, less critical use cases. But for those massive use cases where there's terabytes to petabytes of data, millions of requests per second, the cost of deploying and hiring a team to manage that deployment greatly outperforms those cloud offerings to the tune of millions and millions of dollars per year. But those cost savings don't come for free. Deploying an open source database is often significantly more complicated than just taking the cloud offering off the shelf, taking its client tool and giving it to your users. And that complexity often comes down to people and tooling. Open source databases are used by a multitude of people. Often their vendors are trying to offer a product alongside, whether that be their own cloud offering or support. And those sales goals can have influence on the product. There's a community that can both be relied upon and used or like we worked with to your benefit, and we'll talk about that. But that community may also work against your goals. And then you have internal needs. Ultimately, our goal is to provide a service that's best for the businesses that we work for. And that may be at odds with the desires of the other businesses and teams that are deploying that database. And so we'll cover dealing with all of that. But before we dive in, let me tell you a little bit about me. I've been working as an engineer since I was in high school, so date myself a little under 20 years now. And for the last decade or so, I've been focused primarily on databases, developing them, deploying them, using them, providing them as a platform to companies I work for. And today I do that for Netflix on a team called the Online Data Stores team. We're responsible for providing the paved path set of data store offerings to the entire company for everything from streaming to content creation to games. And so to do this, our team offers 8 different data stores for different use cases, including Apache Cassandra, CockroachDB, Memcache, and several others. And for each store that we provide, we've evaluated that build, deploy, or buy decision. Prior to Netflix, I was at Apple, which is well known for being one of the larger Cassandra deployments in the world. And I'm also an Apache Cassandra committer, where I've spent time focused on secondary indexing and stability and quality of the database. In short, I have a lot of love for databases, especially open source ones, and a good amount of experience using them. So back to open source databases, deploying them. Why can't you just install whatever package the community provides, call it a day, run RPM install Cassandra, and then, run the service and go for coffee. Well, you can, and that may work early on, but if you're going to take on this additional effort of deploying an open source software, you should also really reap the benefits. There's no point in kind of just installing the package and making more work for yourself, without getting some of that benefit. And the biggest benefit of deploying versus buying really comes down to control, being able to twist and turn little knobs, push various buttons that you wouldn't have access to from a cloud offering. And often data stores that are offered as part of a platform, and platforms themselves are products, maybe not for profit, like, your internal platform isn't trying to make money per se, but it is for the benefit of the company. And so if you're going to invest in a team, you want to take advantage of the choices you've made. So if you are going to deploy, that control is something to take advantage of. And again, when you buy from a cloud offering, there are all sorts of other advantages, but how tightly you can integrate with your platform's ecosystem isn't one of them. The tools you choose to monitor with, your alerting and on-call tooling, your provisioning experience, your ability to resolve incidents, all those may be dictated by the cloud service, whereas when you go to deploy, you can choose how they integrate with your platform's ecosystem. Um, and in both cases, unlike the build from scratch option, people have made choices for you. But because open source is open, that ability gives you leverage. So it actually kind of gives you a head start and leverage to make this product your own, to integrate it where you need to, smooth out rough edges that have scraped you, that have caused incidents or been difficult for your users, and leverage to provide a better quality of service at a higher standard than what you may be able to buy off the shelf. So how do we take advantage of this benefit? That's going to be a large focus of what we talk about today. And the answer lies, going back to that initial question, more than just installing the package and going for coffee, but to take that open source database, crack it open and customize it. So that customization tends to bring the idea of forking to mind. And we will talk about forking. This may be the option you choose. We have in some cases, and I'll talk about those cases. But customizing comes in many different forms, not just only the traditional, like clicking the fork button on GitHub. These include building plugins, writing sidecars, patching, or the true fork. But like all of the decisions we're going to talk about, they have implications and trade-offs, and we'll dive into these a bit. So I think the ideal way to sort of extend or modify your open source database is through this idea of plugins. This is ideal because you sort of get to manage the code in an official way for the database, the code that you're using to modify the database, but it still lives entirely out of band of the core database itself. So in Cassandra, for example, there are some interfaces you can implement in your own code base, and then you load that jar into the Java class path. And then you can specify via configuration, like, hey, I want to use my class for this piece of logic instead of another class. So you can do this for like customizing secondary indexing, or a few other means. And we also do this for Netflix's version of Memcache, which we call EVCache, by linking in our own dynamic libraries. Plugins are often ideal because really the only work, like sort of modifying the database, is to link in the code through whatever means the language the data store written in uses. So like for Java, it just means like sort of modifying the way we start up the database to include our jar in the class path. For C, C++ projects like Memcached, it means linking in shared libraries. And pretty much every language that a data store has or would be written in has this functionality. And again, the plugin sort of minimizes complexity, allows you to develop changes independent of the changes in the database for the most part. But they aren't always supported, or perhaps we need to customize in ways that the plugin model doesn't support, because again, this is something that has to be built into the database itself for you to leverage it. So the next least invasive approach is the sidecar. This continues to let you develop independent of the code base. That independence allows you to develop free from the choices of things like, for example, the build tool. So Cassandra um, still uses Ant, which most people aren't familiar with these days. And so, adding things like dependencies, et cetera, can be tough. Whereas for Sidecar, you can pick your own build tool. So for our Sidecar, we use Gradle. And so the sidecar is often useful when building controlled planes or additional features that aren't core to the functionality of the data store. At Netflix, the sidecar we have for Cassandra is called Priam. We use it in a variety of ways. One of the most important aspects that we use it for is our robust backup system. So Cassandra provides sort of the building blocks of a backup system, namely the ability to take a snapshot of a node's data files. But all of the rest of the glue is missing, like how you get those files to somewhere that's not on the machine they're running on, how you deal with addressing those backups and organizing them. And so that's where Preem comes in. It drives the snapshot functionality that's already in the database, among other things, and ensures those files make it to a cloud object store for disaster recovery, for data movement, or to other data stores like our data warehouse or our data mesh products. We also use the sidecar to add HTTP-driven control to Cassandra. So Cassandra only has a command line tool for a lot of the administrative operations, like restarting a node or changing settings via JAMX. So our sidecar lets us access those tools remotely with the control that we need and integrated into sort of like all of our tooling, authentication, authorization, all that sort of stuff. And so they're a great, easy way to extend the database when plugins aren't an option, but you don't want to like fully crack open the database just yet, which is what we'll talk about as the next option. So the sidecar and the plugin aren't always enough. Sometimes there's logic you really want to change in the data store itself. Maybe a bug or a rough edge has been plaguing your users and you can't wait till the next release. Maybe you're going to backport a change, or there are features you want to turn off. And those rough edges maybe aren't bugs per se, but they still cause harm in your experience in a production environment. And so if you've reached this point, there are sort of two options left, both which involve modifying the code and come down to how often you modify the code. And so the difference is really in how you do this modification. The patching approach is best suited when you have a small number of targeted changes. Let's say 10 or less. You might even find that after 5, this approach starts to get unwieldy. But it's a great place to start, and it's sort of an easier way to start than the full-on fork, which we'll talk about next. And so with the patching approach, what you do is you make your code modifications, and then most likely with Git, but with whatever version control system your data store uses, you generate a patch of those changes. And then when you go to do a build, you check out the source code, apply the patches that you've made, and then go and actually do the compilation of the project. This is advantageous because you have a really easy way to list out all the patches you've made. You just go to the repository of patches. That's all that's in there, plus the logic to apply them. And you can see everything that you've changed when you are dealing with new versions or new releases of the database. You quickly find where your patches don't work anymore because they failed to apply. And but the downside here is that they're hard to read. So reading a patch file can be a real pain, to see all of the removals without all the full context and all the additions without all the full context. And so often as a developer working on, a piece of software managed this way, you have to actually go apply all the patches. And so you have a separate kind of editor's build that just applies the patches and then makes the code base available for, viewing in your IDE. And then also when the patches fail, you kind of have to start, not from scratch, but you apply the patch and you're sort of doing this like manual merge commit process. But again, that's why we only do this for a few small, like when we have a small number of patches. And so this is the approach we take for EV cache, which is more of a wrapper around memcache, and there's very little we change in memcache itself. So for those small number of changes, it's easier to take the patching approach. But as the number grows or the patch dependence on each other starts to increase and that complexity increases, then it may be time to go with a full copy of the code base or a fork. And so the true fork is how we manage our Cassandra build and how I've managed Cassandra builds in the past for large deployments. We do this because we have many patches, 10, 20, 30, maybe even 50, and all of them are invasive to some degree. Perhaps they remove the ability to use certain features. Some are backports from previous versions or from future versions. So we may have a patch from Cassandra 4 that we want in Cassandra 3, and we know the community won't be providing it as part of Cassandra 3. We may be trying to fix a complex production issue that we've ran into that we need to prevent in the future as a matter of importance to the business. And so we've decided that despite the fact that managing a fork takes the most work, that it's worth it for us. And that additional work comes in because upgrading is now a practice in merging from a code base that's moving independent of the changes you've made. It means learning what changed in the database and having more deep understanding, ensuring that when we have merge conflicts, they're fixed correctly. But we make that trade-off because it gives us really granular control of what we release to production. We're no longer tied to the release cadence of the database itself. And this extra control is beneficial, even though it comes with this additional effort. And so what you'll see is in practice for us, and I've mentioned some examples, we don't just use one of these strategies, we use a combination. So to provide Cassandra to the company, we use actually three of the 4 techniques here. And as I've mentioned, for like EV cache, we use a different subset of techniques. So for Cassandra, we use plugins, and some examples of those plugins are we load Java agents for things like Cassandra exposes metrics over JMX, and we want to get them into our metric store. We also modify the cryptographic algorithms implementation that Cassandra uses. So we sub out the default JVM cryptographic implementations for Amazon Credo crypto provider for performance wins. We use the sidecar preem that I mentioned to implement control plane features and features that are not first class features of Cassandra, like the backup system and also scheduling repairs. So Cassandra has the ability to repair a replica set, but it doesn't really have like all of the logic to make sure this is an ongoing process. And so we build that into our sidecar. And we use the fork to make deeper changes. Backporting is a big one. So for example, there are some features around scheduling compactions of the data that we wanted that were in future releases that we wanted to pull back into our version. We also block features. So we've had a lot of problems with a feature called materialized views in Cassandra. And instead of letting our users sort of like find that rough edge, break it, and then have a production incident, we just turn it off. And we have like a custom message that says, please reach out to our team and we'll talk you through, how to accomplish this without this feature. And we also extend the database. So for example, Cassandra will take a snapshot when you truncate a table based on configuration. And for disaster recovery purposes, we've built tooling that imports that snapshot back across the cluster and does so in a safe way. So if a user ever accidentally, say issues a truncate in prod when they meant to do it in test, we can recover quickly. So like many things in software, one solution doesn't fit all. We regularly weigh where our changes are best to go in these areas. Do we take the extra cost of modifying the database itself and managing that patch, or do we try to do it externally in a sidecar or a plugin? And we, evaluate where it would best fit on a case-by-case basis. So getting your development and deployment model in place is really one of the biggest hurdles in deploying open source database yourself. And that's been why it's been the major focus of this talk. But there is more to consider. One of the most important things is how you will qualify and perform upgrades. With a cloud service offering, typically, although not always, the upgrades are seamless to you. You may not even know they're happening. Um, and you just kind of continue using them. And so the goal for the database you deploy is to make those upgrades as seamless as possible too. You want your platform to be as convenient for users as a product that's offered to them. And so to do this typically means both keeping up with the development of the database itself and doing rigorous testing before you upgrade. This is important to make sure that what has been working hasn't been broken, but also to understand what has changed or been fixed. A former colleague of mine in a past job once said to me that one of the biggest challenges of a major version upgrade in Cassandra is making sure that what was broken before is broken in the same way, or if it's not broken anymore, how you can get your users to deal with this new behavior, because people often have come to rely on the broken behavior of a piece of software, and it being fixed or that brokenness changing in some way has to be accounted for. So at Netflix, we're currently migrating from Cassandra 3 to Cassandra 4, and we've been going through this process ourselves. To qualify release, we've tested on a variety of workloads. That's 10s to 20s of clusters with sort of different workload patterns, using different features of the database, trying to cover the entire footprint of the different ways you can use Cassandra. And we do this by duplicating traffic to an upgraded copy of the cluster. So we have a lot of tooling, both at the client layer as well as at a proxy layer, to be able to duplicate traffic to another cluster, and then do things like compare responses. We can also pull data through our data movement products and compare that what's output is the same between the two versions on a row by row basis. And then we also need to ensure that all of our tooling, the sidecar, the data movement code, the plugins, the metrics, that they all work as expected. And so this is a big undertaking and one of the bigger considerations when you're exploring that deploy versus buy decision. Worse than a regular upgrade is one where there are breaking changes. So a great example of this is the Cassandra 2 to 3 migration. The Cassandra 3 introduced a new storage engine that broke some of the old Thrift API that was sort of not replaced, but Cassandra CQL was becoming the first-class citizen in terms of how to access the database. And so the storage engine was built with that in mind. And to put this into context, we are still working on the Cassandra 2 to 3 migration while we do the 3 to 4 upgrade because of these breaking changes. And so when breaking changes are introduced, the migration is often necessary. And this can be a really painful process, both for you and your users. For you, during a migration, you might be getting a lot of benefits post-migration, but those aren't always immediately and readily apparent to your users. So for example, maybe there are some easy wins like performance improvements that you can pitch them on, but a lot of times like the new features that are coming with a new release that may have caused those breaking changes, those aren't things that your application teams are readily going to take advantage of, because they have to modify their code base to use those new features, and they're already spending time modifying their code base to do your migration, and they have other business needs to address. They have features and commitments that they've made to other teams, and so you're starting to compete with their time and don't have always the best value proposition. And so ideally, database developers are aware of this. And, so for example, the reason the Cassandra 3 to 4 migration or upgrade is not a migration is because this was much more well thought out than between 2 and 3. But sometimes this happens. And so when you do have migrations, they require focused campaigns and a strong partnership with your users. Probably in and of itself, migrations could have their own 30-minute talk at this summit. So I'm not going to dive deeper into them here, but I did want to highlight them as something that you have to consider when you deploy. Another thing to consider is contributing back. Doing so can have a lot of benefits. For example, getting ahead of bugs, having a path to influencing the future of the data store you chose. But it also comes with its own choices, like how to modify and the different forms you can take. And again, a mix of strategies can be the best approach. So I think in my ideal world, we would contribute first. That means contributing your changes before you deploy them, but it's really rare that we do this with Cassandra. And that's because the time to submitting a patch and a release is just too great for us to wait. We can't tell our users, hey, we've got this fixed, but it's going to be, multiple months until we put it out into production for you. But you have less upkeep costs because now your changes are the product changes or the product's changes. You have other eyes reviewing your code and potentially using your code and testing it before you do. And so it comes with those benefits, but again, at the cost of, sort of like a longer time to release, which is often not acceptable for us. So the approach that we take most often is to contribute after. So this means we've already deployed the change into production. Maybe it's actually been in production baking for a couple weeks or even months. And so this reduces our time to get the change into production, but it comes with this upkeep cost of now we have more in our fork that's different than the database itself. As we merge and update or as we upgrade, we have to bring it forward. But it's useful when you have like minor changes or bug fixes that you need out right away. It's also very community dependent how painful or not painful this is, but it's the approach we choose most often to balance, our internal users with our needs and the community's needs. And then what I think is the least ideal approach, but we take it sometimes for a variety of reasons, is to not contribute back. Sometimes it's appropriate. In rare cases, it's because of how the project is governed or licensed, but more typically, it's because the change only has value to you. So for example, I mentioned that we turn off some features that we think are rough edges of Cassandra. And we know the community is not going to want that change. They built that feature. There may be uses for it at different scales or at, in different ways than our users have wanted to use it. And the plan may be to roll forward, to fix forward and fix the issues with the system. And, we may pull our patch then, but it just never makes sense to give that patch back to the community. And so in some cases, we contribute never. Whether you decide to contribute patches or not, you can still get involved with the community. This can have a lot of benefits for you. The knowledge you'll gain will help you provide a better service. You may get ahead of bugs that have been discovered, and you may be able to influence the roadmap itself. So we often meet with other users who are of a similar scale to us to get an idea for what they're doing, what roadblocks they've hit, what wins they've had, and see how we can learn from that to make our service better. And also we've leveraged those relationships to get out of hairy incidents before. So we had a pretty large incident a couple years back, and we, were spending a lot of time trying to root cause it. And instead we reached out to some community members and said, hey, have you seen this sort of weird set of events before? They immediately knew what was wrong. And so now we switched from spending a whole bunch of time root causing to going and fixing the issue once we understood, what was underlying it and how to fix it properly. So having those relationships is a huge win and helps us provide a better service to our teams. And so that brings us back to the question we started at, when presented with the choice of build versus buy versus deploy, why deploy? Deploying, in my mind, is the middle ground in the build versus buy decision. You get to use a product that's used by many other people while having control over things like cost, quality, and features, plus the ability to integrate with your own internal tooling, your own metrics, your own on-call process, your own platform. Is it always worth it? Absolutely not. But when it is, the dividends are super, super easy to realize. The leverage is really high. The dollars saved can be astronomical. And the benefit to you and your team can be as well. So thank you for taking the time to be here today. Again, to the organizers for hosting such a wonderful event. And if there are any questions, I'd love to discuss with you further here in the chat, or you can reach me online. Thank you.